Hello everyone, welcome to this video. In this video we'll be talking about sequences of projections. Now suppose you have certain projections, say P1, P2, P3 and so on, and all of them are a portion of some sequence, right? Then what can we say about its convergence? So that is the question, and moreover we have already defined what is a relation between these kind of projections, right? So what is that relation? We have defined that relation to be monotonically increasing relation, or it could either be monotonically decreasing relation. So that relation between all these projections is defined in a way, right, in a way of posets, if you remember, partially ordered sets, right? So now according to this result that we have here, let's see what can we say about the projections, its convergence, and what about the convergent projection. First of all, whether it is convergent or not, let's first see that result. So here we have a theorem. It states that suppose this Pn, where n is the index that represents a monotonically increasing sequence of projections Pn. So this is given to us, right? And all of those projections, they are defined on the given Hilbert space H, right? So the first result here tells us that this sequence would be strongly operator convergent. So if you remember, what do you mean by strongly operator convergent? It means that whenever we have the convergence would be there for every element which x which is a member of the Hilbert space, and it is not that the result would be there only for few elements, but in case of strong convergence the result would be there for every element x which is a member of the given Hilbert space, right? So in this case the sequence would be strongly operator convergent, and the limit operator that we represent that by P, that would also be a projection, and which is also defined on the given Hilbert space, right? So this is the result. So the first part here, it tells us that the given projection would surely converge, and it would converge to some operator P which is also a projection, right? So where does this projection now maps all the elements? So it would map the given Hilbert space to where? So the second part here tells us that it would project the given Hilbert space onto the projection, onto the space where we have the union of all those projections, the union of all those image space of the projection. So if you remember, for P1 we have P1 mapping the Hilbert space onto Y1, if you have P2 mapping H to Y2 and so on. We keep on doing like this. So what would be your P? Your P would map all of this Hilbert space to Y1 union with Y2 union with Y3 and so on, right? So it would be the union of all these things. And what would be the null space for this particular projection? It would be equal to the intersection of all the null spaces for the projection operators which are the member of the given monotonically increasing sequence of projections, right? So this is the result about projections and basically monotonically increasing sequence of projections. So I hope you understood this result well. Well, that is it for this video. Thank you for watching.